In this lesson, we're going to tackle some more challenging L'Hopital rule problems. So make sure you finish the last lesson and you understand it well before moving on to this one, and make sure you have notes and examples written down from that last lesson to reference to. So we're going to tackle just one plain old limit problem, and then we're going to look at some more interesting ways you can run into this rule. By the way, I got auto-corrected here. There is no S in L'Hopital. Okay, so for this first limit, I'm going to check. So I can be pretty sure that the rule will apply because it's a L'Hopital rule problem, but I'm going to still show that it applies, right? So I'm going to say the limit as x goes to 0 of the numerator. Well, let's see. E to the 0 is 1. 1 minus 1 is 0. And then the limit as x goes to 0 of the denominator. Sine of 0 is 0, and 3 times 0 is 0, so this is also 0. So we have a 0 over 0 indeterminate form. So we're going to use L'Hopital. So my original limit is going to be equal to the derivative of the numerator over the derivative of the denominator, and the limit of whatever I get there approaching as x approaches 0. So that would be the derivative of e to the negative x is negative e to the negative x by chain rule, right? And then the derivative of 3 sine negative x will be negative 3 cosine negative x plus 3. Okay. And those derivatives, we should be getting to the point where you can do them that quickly. If you have to look at the formula sheet, that's fine, but the chain rule should be coming more and more naturally to you at this point. And then I'm going to plug in 0. So what do I get here? So on top I get e to the 0 is negative 1, and on the bottom cosine of 0 is 1. So I get negative 3 plus 3. 1 over 0. Interesting. So first of all, pause, make sure you know how I got that. So I'm just plugging in 0 to all my variables here. But now I got negative 1 over 0. So you may be tempted to take the derivative again and try again. But notice remember our indeterminate forms are only 0 over 0 and infinity over infinity. So those are the only two we're looking for to apply L'Hopital. This is not one of those, right? This just means something we already knew. So this means that our limit is undefined or does not exist. Okay, so we enter does not exist for this problem. So just doing this one to show that it's a possibility. You will get problems where you get answers here, obviously. Make sure, even though it's like not super necessary here, make sure you're checking in your work that L'Hopital applies. It's just because it's good practice for the AP exam. And then watch out for this case where it seems like we might want a L'Hopital again, but actually the answer is just it does not exist because we got a 0 in the denominator and something other than 0 on top. Okay. Let's look at some more interesting problems. So given the selected value of the function f and its derivative in the table below, determine the value of limit as x approaches 1 of blah 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 in simplest form. Okay, so let's check the top and bottom. Let's see, f of 1 is negative 2, and then, so this becomes negative 2 plus 2, which is 0. And then the bottom, let's see, we get 2 minus 2 rather, here, when we're plugging in 1, so we get 0. So this tells us we have an indeterminate form. And then by L'Hopital, we'll say f prime of x is the derivative of f of x plus 2 over 4x minus 2. Okay, and then f prime of 1 is negative 4. So we get negative 4 plus 2, and then 4 minus 2. And this one's going to work out nicely. So we get negative 2 over 2. Okay, so I can present my derivative in a different way, right? So we don't know what f of x is, but we know enough information to solve this particular limit. That was a great time to pause and capture this in your notes and make sure you understand what I did before you move on. And I guess because it says in simplest form before we move on to the next one, we'll simplify this. So this ends up being negative 1 is my final answer here. Okay, last one. Very similar idea in the last one. So I can give you the derivative in a table, or I can give you derivatives graphically. So the first thing we'll do, let's note that this is f. The graph of f is shown below, and we want the value of this limit in simplest form. So we'll check the top. So 2 times f of 0, well, f of 0 is 0, right? So we get 2 times 0 plus 0. And then the bottom, that limit is obviously going to be 0 as well, right? Because every term has an x in it. Okay, so that means we have an indeterminate form. And we are going to use LHopital. So the limit here, and be careful here, so we have f of 2x here. So we are going to use chain rule. So 2 times 2 is 4, and then f prime of 2x. Okay, so just to be super clear, f prime is the derivative of f, and then I multiplied that 2 by the inside 2 using chain rule. So watch for that. Plus 2 is my derivative on top, and then on the bottom I get 4 plus 8x. Okay? And then when I plug in 0, so f prime of 2 times 0, so now we want the slope here, right? So we want f prime, I'm going to write it down here so it's clear, f prime of 2 times 0. Well, that's the same as f prime of 0, which is the slope at this point. So we no longer care about the value of f. The slope is negative 2, right? So what we get for our limit is 4 times negative 2 plus 2 over just plain old 4. Okay, and then this simplifies to negative 6 over 4, which simplifies to negative 3 over 2. Okay, so make sure, remember that f prime on these graph examples, f prime of x, as always it's the derivative, is the slope at x. Okay, and then the other thing to note is use chain rule if you have a function within a function. So don't forget chain rule. So remember to use, if you're stuck, use the delta math examples, come back to this video, or check out the delta math video to help you.